Okay, welcome back, everybody. We have a nice 5-day week. We have a good chance here to get as much as we can done before spring break. I think you're all working hard at that. So I'm here to thank you and recognize how hard everyone in here has been working. And I know it's not easy, and I'm here to help. So this is going to all be about circles. This is 9.3. Once again, we are just using Pythagorean theorem for circles. So here, this is something that some of you guys are already here, but I want you to pay, like you're already past this section. Pay attention to this, because this is kind of just a good way for you to connect some things. Would anyone like to define a circle? What is the definition of a circle? It is a set of points.
It is equidistant to a point.
Equidistant to a point called the center. That's exactly right. Okay, so we're going to call the center H, comma K. So get used to that. Those are going to be those letters are going to be used a lot. And then all the points on the circle we'll call X, comma Y. Okay. Now, what do we call the distance from the center to the points? This defined distance. What do we call that in geometry?
Radius?
That's the radius. Now, you all just finished the right triangle section, or you're almost there. So we can do this now. Watch this. From here to here. How far right do we go to get to the green point? How far right did we go to get to the green point? What letter is that? Nope. X. We went to the right X to get to the green point. How far to the right do we get to go to the red point? How far right do we go to get to the red point? H. We went H. So therefore, I can't undo this, so I'm just going to leave that there for now. This segment here is X minus H in length. Can you kind of like try to process that? And then similarly, this, okay, how far up did we go to get to the green point? We went up Y. How far up did we go to get to the red point? We went up K. So what's the length of that? Very good. It's Y minus K. So that was quicker for some of you guys. And now, how are all these things related? I'll get to a color where you can actually see it. Well, this is a right angle, right? So X minus H squared plus Y minus K squared equals R squared. And does anybody recognize that?
Looks like distance.
It does look like the distance formula, but this is actually the equation for the formula of a circle. It's the set of all points X, comma Y that are a set distance away from the center H, comma K. So that's why this looks so familiar. It's just Pythagorean theorem, okay? Boink, boink, boink. So look, there you go. This is straight out of your book. Many people memorize this. It's so much better to understand it. And then this is really important as you move into algebra. When you see a minus H in a parentheses, what it does to the graph is counterintuitive. It's actually going to go right H. Not left H, right H. And the minus K is going to go up K because of the Y. And I'll show you some examples. Okay? So, this is very challenging. It's called completing the square. And it's something you do so that if you have something that's written in what's called standard form, you write it in a different way so you understand what that looks like as a circle. Okay? So here's the process for this. Take your x squared and group it with your x term. and leave yourself some space, okay? And then take your y squared and group that with the y term. And leave yourself some space. And then move your constant over to the other side. So I'd have to subtract 16 from both sides. So does everybody understand what I've done so far? Now here's the point where we complete the square. Here's how you complete the square. Take half of the b term. So what's half of -6? -3. Square that number. Don't tell me it's negative. What's -3 times -3? That's a +9. But I can't just go willy-nilly adding 9 to things on the left side if I don't also add 9 to the right side. So far, so good? What is half of 8? What's 4 squared? So I'm going to add 16 there, and I'm going to add 16 there. So now, you've got these two trinomials. Give me two numbers that multiply to be +9 and add to be -6.
-3 and -3.
-3 and -3. So this factors to x minus 3 times x minus 3. But when you multiply something by itself, what's that called? Squared. Oh, now it's starting to look like the circle formula. What are we going to get for this one?
4 and 4.
Yep, y plus 4 squared. And then what do we get on the right side?
9.
We just get 9. Oh, now I get it. This is right 3 down 4 radius equals, be careful, it's not 9. Radius is 3. That's how I would graph that now. And now, all I have to do, I'll just sketch a really crappy one. Right 3, up, down 4. Radius is 3, so it's going to just barely touch here. It's going to look like that. Is this a function? It is not. Because it fails the vertical line test. I could not graph this in my calculator under y equals. I'd have to use an app, or I'd have to use Desmos. If you are using your graphing calculator, there is an app, not a program, an app called Conics. Try it if you want. And the other thing is, again, this is really good. This is the best thing about the Cinemation Lab math thing. This is exactly like Unit 10 in Algebra 2. So if you do a good job of learning this, next year when you're in here for Algebra 2, you'll fly through that chapter. You're going to get finished with Algebra 2 so much faster than geometry because you're starting to learn it better. You're remembering it better, okay? Let's see if we have any more slides. I think this is it. Let's see. We're way over 5 minutes. Yep, that's it. Boom!